Playwright version 1.56 has just shifted our test maintenance from writing better selectors to relying on AI-driven repair. But QA teams are making a massive mistake right out of the gate. They are treating these new AI auto-healing tools as a blanket solution, throwing them at every broken test without a strategy. On one side, teams enable runtime auto-healing globally. They get fast, green builds, but they are silently masking genuine application bugs behind a wall of false passes. On the other side, teams deploy heavy structural AI agents on every single pull request. Suddenly, their LLM token bills are tripling just to fix minor CSS tweaks. The goal of your pipeline is to categorize test failures accurately. You need to stop the noise of test flakiness without letting actual broken code slip into production. Getting this wrong, failing to route failures properly between a quick patch and a permanent rebuild, will cost your engineering team more money and reputation than a broken selector ever did. To understand how to route these failures, we have to establish what these tools actually do. Modern AI testing agents are incredibly good at mapping and understanding the exact structure of your document object model. But they have a strict limitation. AI agents have zero comprehension of your business logic, complex feature flags, or the non-obvious product requirements dictated by your users. Because of that blind spot, human QA judgment is still strictly required. Someone has to interpret what a specific test is actually trying to verify. You have to treat AI in testing as a maintenance accelerant. It handles the syntax, but it cannot replace the contextual product knowledge of a QA engineer. Let's look at your speed-focused option. Runtime auto-healing tools, like BrowserStack's Self-Heal or LambdaTest's KaneAI. Activating this requires a simple configuration flag in your setup, like setting Self-Heal True. When a locator breaks, the tool intercepts the failure and dynamically substitutes an alternative locator right at execution time. The pipeline stays fast and the build stays green. This works perfectly for the daily noise of UI development. It handles renamed classes, updated data attributes, or buttons that shifted into a different container. The severe trade-off here is that a runtime patch cannot distinguish between a cosmetic selector change and a feature that a developer intentionally deleted. Look at this UI diagram. If a critical checkout button is removed from the page, the AI doesn't know the business logic. It just scans the DOM, finds a visually similar element nearby to click instead, and forces a pass. The immediate consequence is that the user journey is entirely broken, yet your CI pipeline cheerfully reports a successful green build. This is an invisible false positive. It accumulates technical debt silently and bypasses QA review entirely, making it far more dangerous to your product than a standard red build. The alternative to that runtime patch is the structural integrity-focused approach, the Playwright Healer Agent, introduced in version 1.56. Instead of a config flag, engineers trigger this via the command line using npx playwright init agents. This executes your failing tests in debug mode. The healer stops and inspects page snapshots and console logs to find the root cause. Then it outputs permanent code rewrites for you to review in a pull request. Its most vital differentiator is honesty. If the healer determines a feature is genuinely broken, it doesn't force a fake pass. It annotates the code with test.fixme and surfaces the bug. But the trade-off is speed. The plan generate heal loop dramatically slows down pipeline execution times. It also costs money. A single healing loop for a medium complexity application uses roughly 30 to 60 cents in LLM tokens. This line graph tracks those costs at scale. If you run the healer indiscriminately on 200 pull requests per week, that compounds quickly, scaling to $10 or $20 weekly for a single medium-sized app. The healer agent guarantees structural test integrity and surfaces real bugs, but the financial cost demands that you budget it strictly and restrict it to specific persistent failures. There is also a technical constraint to watch out for. The Playwright agent gains deep context into your application state through Model Context Protocol, or MCP servers. The hidden danger of this deep integration is context bloat. Connecting too many MCP servers simultaneously instantly consumes up to 20% of your LLM context window before a single test runs. If you fail to manage which tools are active, you will truncate your complex test logic and waste expensive tokens processing useless background context. To fix this, you must stop treating auto-healing and the healer agent as competing choices. The definitive architecture requires you to layer them. This flowchart shows the strategy. Layer 1 is your first pass CI. You route all initial cosmetic failures into the runtime auto-heal bucket to catch the noise of active UI development and maintain your execution speed. Layer 2 is the second pass CI. Tests that fail across multiple runs are persistent structural failures. These bypass auto-heal completely and route directly into the Playwright Healer Agent. Isolating the healer strictly to this second layer drastically cuts your LLM token spend, while guaranteeing that structural DOM changes are actually addressed with permanent code updates. Layer 3 is the quarterly human audit. You must take the temporary runtime patches from Layer 1 and manually replace them in your codebase with stable data test ID or semantic locators. This 3-layer pipeline captures the fast execution of runtime patches, uses the healer to definitively block false positive bugs, and slowly permanently hardens your test suite. One final warning on maintenance. The agent definitions generated by Playwright are living configurations, not a one-time set-and-forget file. You must regenerate these definitions using the init agents command every single time you install a Playwright update. For the SDETs watching, deliberately isolate your critical path logic tests, route them exclusively to manual review, and keep auto-healing far away from them to prevent false screen builds on your most important workflows. For QA leads managing budgets, aggressively monitor that Layer 2 agent loop. Restricting the healer to persistent failures is the only way to keep your monthly LLM token spend under control. AI tools eliminate the tedious work of fixing broken syntax. They clear the noise so that you, the QA engineer, have the space to orchestrate high-level pipeline judgment and ensure the